Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the real zeros of a polynomial function, part 2, rational zeros theorem. So this rational zeros theorem is to identify the possible rational zeros of a polynomial. For example, in that polynomial function, we have the zeros of 2, 3, 3 over 2, 1 over 2. So this is all the example of the rational number. So, how can we make use of this theorem? When we have this polynomial function and we know that an is the leading coefficient and a naught is the terms without x, so that is what we call as a constant term or constant coefficient. So the rational zeros theorem give here plus minus c over d, where c is a factor of the constant term and d is the factor of the leading coefficient an. So let's look at to the first example here. Determine all the possible rational zeros. So we have here px is equivalent to 2x cubed plus x squared minus 13x plus 6. So from here we can detect the a naught is equivalent to 6 and our an is equivalent to 2. And the factor for the a naught, which is the values of c, is equivalent to plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So the factor when you divide by that numbers, so you will not going to get a remainder, or the remainder is 0. And then the factor for the values of 2 is d, which is plus minus 1 and plus minus 2. Therefore, the rational zeros theorem c over d, so every c you need to divide by d. For example, 1 divided by 1, so you will get 1 plus minus 1 for the first rational zeros, and then plus minus 2, plus minus 3, and plus minus 6. So how can I get that value? So 1 divided by 1, 2 divided by 1, 3 divided by 1, and 6 divided by 1. And then the next one, 1 divided by 2, 2 divided by 2, 3 divided by 2, and 6 divided by 2. So if the number is repeated, you don't have to write down again. So the next one we have here plus minus 1 over 2. And then the next one, 2 divided by 2, so you will get 1. So we have already 1 here. Then the next one, 3 over 2. We don't have 3 over 2 just now, so plus minus 3 over 2. And the next one, the zeros is 6 divided by 2 is 3. So we already have 3 just now. Therefore, this is all the possible rational zeros. So we have 1, 2, 3, 4, 5, 6. So there are 6 times 2, so 12 possible rational zeros on this polynomial function. So let us try to, this is all the possible rational zeros. So when you try to use your calculator to get the zeros of this polynomial, when the zeros is rational number, so the zeros is among that 12 possible rational zeros that you get just now. Okay, can you try out for the B? Okay, let's look at to this exercise. Given a polynomial pxx power 4 minus 10x power 3 plus 27x squared minus 2x minus 40. So find the maximum number of zeros for this polynomial function. When the degree of polynomial, the higher degree of polynomial is 4, so the maximum number of zeros is equivalent to 4. So therefore, there are 4 maximum number of zeros of this polynomial. And then we need to use of discard root of sign to find all the possible zeros of px. So by using discard root of sign, we have to detect the variation in sign here. So we have the first variation, positive to negative. So this is the first variation. This is the second variation. And this is the third variation. So there are 3 variations, meaning that there are 3 or 1 possible positive real zeros. And then the next one for you to detect the negative real zeros. So we have to substitute x with the negative x. So you will have here negative x power of 4. Make sure you put the bracket the negative x inside the bracket, and then power of 4 is outside the bracket. And then the next one, minus 10 negative x cubed, and then plus 27 negative x squared minus 2 negative x minus 40. So when you expand the negative x, so you will get positive x power 4, and then positive 10x cubed, and then minus positive 27x squared plus 2x, and then minus 40. So in this case, we have only one variation in sign. Therefore, they are one possible negative real zeros. So make sure you put the word negative real. So we have also the zeros which is complex zeros. So you need to put the word real and also whether it is positive or negative real zeros. And then the next one for the part C, use the rational zeros theorem. So for this case, our A node is equivalent to 40. So you need to find out the factor of 40. So we have so many factor of 40. So you need to find out. And then the values of AN is equivalent to 1. Therefore, our D is just equivalent to plus minus 1. So you have so many possible because the factor for 40 is bigger. Okay, and then you can try out C, D, and also E. For the part D, factorize the polynomial px completely. So what you need to do here is, so among the possible rational zeros that we get from the rational zeros theorem. So for example, from the rational zeros theorem, among the zeros, the values of C over D is equivalent to plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 8, plus minus 10, and then plus minus 20, and plus minus 40. So this is all the possible rational zeros from this polynomial function by using rational zeros theorem. And then the zeros of the polynomial function, if it is a real zeros, it comes from all these numbers. So for example, how can we know? So you can test one of the values. So if you want to test one of the values, you have to make sure you have to test the lowest values first. So don't try out the values of 40. So for example, we test the values of 1 or negative 1, 2 or negative 2. If we have half, so we can try out the values of half. So for this case, when I try the values of, let's say, negative 1, so when I substitute negative 1 inside the polynomial function x power 4 until minus 40, so when you get the remainder is equivalent to 0, meaning that x plus 1 is one of the factor of this polynomial function. So once you get one of the factor, what you can do here is we can use that zeros, which is negative 1, to find out another 3 zeros. So for this case, since our factor here is in terms of x minus c, so of course we will use synthetic division. So by using synthetic division, 1, negative 10, 27, negative 2, and negative 40. By using that synthetic division, so we have here 1, negative 1, then we have negative 11, then this one is positive 11, 38, and then we have negative 38, then negative 40, positive 40. So you should get the remainder here is equals to 0 because you make use the values of zeros, therefore the remainder should be 0. So what is the values of the 1, negative 11, 38, and negative 40 stand for? This is the coefficient of our quotient. So once you know the quotient here, you can arrange the answer in form of px is equivalent to, since you are using the divisor of x plus 1, so we will put the divisor first, and then we can put the coefficient of the quotient, which is x cubed minus 11x squared plus 38x minus 40. So this is the quotient, and of course the remainder is 0. So the question asks you to factorize completely, so what you have to do with this cubic, so you have to factorize again. So you can test the values from one of the values from the rational zeros, or you can also use factoring by group, or you can check first by using your calculator. So when you check by using your calculator, another zeros from this polynomial is when your x is equivalent to 2. So when you substitute P2, you get also the remainder is 0. So what you have to do with the values of 2, you have to apply synthetic again. If the polynomial or the quotient, you cannot apply factoring by group. So the values of 2 here, so we have to reduce this quotient. So 1, negative 11, 38, negative 40. So in this question, it is impossible for you to apply factoring by group. So that's why we have to show the synthetic division. So by using synthetic division, you will get another quotient, which is in this case 1, 2, negative 9, negative 18, 20, then positive 40, and you will get again the remainder should be 0. So again, this is the quotient or another quotient. So you can reduce this one to x plus 1, and then, so let me erase this one first. So you have just now px is equivalent to x plus 1, then x cubed minus 11x squared plus 38x minus 40. So just now you are using the divisor of x minus 2. So we will put x minus 2 here, and you have to put the coefficient of the quotient here. So when you put here the quotient, you will get x squared in terms of quadratic, and then 9x plus 20. So once you get quadratic, you can just factorize. So we have here, if you cannot factorize, you have to apply quadratic formula. So x minus 2, then when you factorize this quadratic, you will get x minus 5 and x minus 4. So this is the final answer for the part D, because the question asks you to factorize completely. So when it asks you to factorize completely, everything must be in terms of factor form. And then for the part E, they ask you to find all the solution, meaning that the question asks you the values of zeros. So the solution or the values of x. So our x is equivalent to what makes this polynomial become 0. So it is the values of negative 1, 2, 5, and 4. So this is all the solution of this polynomial function. Okay, can you try out exercise 2 and also exercise 3? So we discuss in class. Thank you.